Today I'm going to show you how to graph the function of y equals x to the fourth minus 3x cubed plus 3x squared minus x. First off, the domain is going to equal all real numbers. To find the y-intercept, you're going to plug in 0 for all the x values to get the y value. So you get y equals 0 to the fourth minus 3, 0 cubed plus 3, 0 squared minus 0. So y is going to equal 0. So we intersect the y-axis at 0, 0. To get the x-intercept, since this is a complex function, you can use synthetic division to simplify this and find out what the intercepts are going to be. Another way you can do it is if you plug in your 0 and your 1 after you find out synthetic division. So I'm going to plug in 0 first, so y equals 0 to the fourth minus 3, 0 cubed plus 3, 0 squared minus 0. So our first intercept is going to be at 0, 0 on the x-axis. And the next way to do it is to plug in 1. So if you go 1 to the fourth minus 3, 1 cubed plus 3, 1 squared minus 1, you're going to get 1 minus 3 plus 3 minus 1. So that's going to equal 0. So our other intercept is going to be at 1, 0. To find the symmetry, you plug in f of negative x into the equation. So it's going to equal negative x to the fourth minus 3 negative x cubed plus 3 negative x squared minus a negative x. So negative x to the fourth is just going to be x to the fourth minus negative x cubed is still going to stay negative, so you're going to be able to do a plus 3x cubed. Negative x squared is going to be positive, so you can just keep that the same. And then your minus a negative x is going to be a plus x. Since f of negative x doesn't equal negative of f of x, then there is no symmetry. Next we'll find our asymptotes. So to do that, we're going to evaluate the limit as x goes to infinity of f of x, which is going to equal infinity to the fourth minus 3 infinity cubed plus 3 infinity squared minus infinity. So you have a large infinity minus a smaller infinity. Then you're going to plus an infinity squared minus an infinity, so it's going to equal infinity. So the limit as x goes to negative infinity is going to equal negative infinity to the fourth minus 3 negative infinity cubed plus 3 infinity squared minus a negative infinity. So you're going to get infinity to the fourth plus 3 infinity cubed plus 3 infinity squared plus infinity, which is going to equal a positive infinity. So as the function, as x goes to positive infinity, the end behavior of the function is going to be increasing. As x goes to negative infinity, the end behavior of the function is also going to be increasing. The next thing we find is where the function f of x is increasing. So from this we can plug in our x-intercepts. So we'll draw a line, plug in our x-intercept of 0 and 1, and then we're going to evaluate at x to the fourth minus 3x cubed plus 3x squared minus x. So if you plug in negative 10, you can see it's positive. If you plug in 0.5, you can see it's negative, and you plug in a positive 10, you can see it's positive. So from this we can tell that f is increasing from negative infinity to 0 and from 1 to infinity. F is decreasing from 0 to 1. So after this, we can now use what we've been learning and find, by taking the first derivatives of the function. So the first y prime is going to equal 4x cubed minus 9x squared plus 6x minus x. And we can break this down by going 4x cubed minus 4x squared minus 5x squared plus 5x plus x minus, the derivative should be 4x cubed minus 9x squared plus 6x minus 1. So plus 5x plus x minus 1. So here we're going to try and get all these, our greatest common is going to be x minus 1. So if you take a 4x squared, we're left with an x minus 1 minus 5x, a negative 5x because you have the negative here, so it's going to be x minus 1. Then you have plus an x minus 1. So from here we'll go and we'll combine. So 4x squared minus 5x parentheses x minus 1, x minus 1. So then we can simplify 4x squared minus 5x by going 4x minus 1 and x minus 1. X minus 1 again is equal 0. So f prime of x is going to equal 0 and 4x minus 1 equals 0, which is going to be 1/4, and x minus 1 equals 0, which is going to be 1. So from here we can put that on a chart. And we can go 1/4 and 1. We're going to evaluate at x minus 1, 4x minus 1. So if we plug in, you can see that's negative, negative, positive, negative, positive, positive. So you're going to find the f prime of x, and you go positive, negative, positive. So it's going to be increasing, decreasing, increasing. So we're going to have, at this point, a relative max and a relative min at this point. So to find the relative max, which is 1/4, we're going to plug 1/4 in to the original function. So you can go 1/4 to the 4th minus 3, 1/4 cubed minus 3, 1/4 squared minus 1/4.